Hi everyone, and welcome to TLDR Week 6 Network Attack and Defense. The learning outcomes for the week, I want you to be able to talk about the different categories of network threats, including scanning and sniffing. I want you to be able to describe the virtues and limitations of some technologies such as firewalls, DNZs, and end-to-end encryption. I want you to be able to discuss security properties and limitations of things like IoT devices, identify additional threats by non-wired devices, talk about things like public Wi-Fi, talk about threats that can't be protected against using secure channels, and be able to diagram a network for security and the use of firewalls. So let's start with the very basic, what is a network? A network is computers that are connected to each other. At the very base, a network is two computers that are connected to each other. The terminology that we use when we talk about a network is a node, that is each device that is on the network. A topology is how the devices are connected together. And packets are the pieces of information that are being sent on a network. So if I have, for example, a network of three computers that are having a LAN party or local area network party. You'll see this in gamers sometimes. If we have three computers that are connected for a LAN party, they're going to want to send information back and forth so that everybody can be in, let's say it's a dungeon crawler, the same place. So we have to have the packets, which contain the information that is being sent, who it is being sent to, and where it is being sent from. And then the topology is how the computers are connected. So what you'll see to the right on your screen here is some example topologies. We can have, for example, a ring topology where the computers are connected in a ring, or we could have something like a star topology. This is really popular for servers where you'd have multiple computers connected to a single server. Some of the things we have to worry about with a network is scanning threats. So Nmap or Zenmap are used to scan a network to get a visualization of the nodes on the network and where they are connected to. Nmap is a really powerful command line tool that can do this. Zenmap is the GUI or graphical user interface version of this tool. And what you can see by using something like Zenmap is we can actually get an image of what the topology is, so who are we connected to and who else is on the network. We can do things like see which ports are open, who's communicating with who, how many packets are being sent. And this can be part of network recon. So if we're trying to do things like find vulnerabilities in a network as a network administrator, we might want to do scanning to find that. We might also want to do scanning as part of our hardening of a system so that we can figure out which ports are open, do they need to be open, can we close them, things like that. Sniffing is where we are actually looking at the packets that are being sent around. So packet analysis means that we are going to be looking into the packets that are being sent. You can kind of think of packets like envelopes. The outside of the packet has who it's going to and where it's coming from. The inside of the packet or inside of the envelope has the letter that we're trying to send. Sniffing can give us the ability to do things like look at the outside of the envelope really quickly. We can also do something called deep packet analysis, where you can actually see the inside of the letter. Now, some of these packets are going to be encrypted at this particular day and age. Hopefully most, if not all, are. Man-in-the-middle attacks are where somebody is able to sniff the packets as they are being sent. You'll sometimes see this on public Wi-Fi. There's also the issue of what's called war driving. This was actually something that Google got into a little bit of trouble for because they sent their cars out. If anybody remembers when they did Google mapping, Google sent their cars out with a bunch of cameras so that they could take street view photographs of basically everywhere in the world. But part of what these cars did is actually also map the Wi-Fi. So they would drive past and pick up any Wi-Fi signals. So they could actually, if you do something like, for example, broadcast your SSID or the name of your Wi-Fi, these cars would actually be able to pick up everybody's Wi-Fi names and place it on a map. So they actually got into a little bit of trouble for war driving. Normally I would demo Wireshark, but as I can't get to campus and I don't really want to demo Wireshark on my personal network, I'm not going to do that, but you will be seeing Wireshark in your networking classes. There's also a bunch of videos of other people demoing it on YouTube. Now, wireless has a different set of threats than a wired network. A wireless network means that we are going to connect to a wireless router. It also means that it's a little bit harder to be able to see everybody on the network because there's no wires connecting. Wireless networks are going to use encryption. The original was WEP, that's cracked very easily. WPA and WPA2 and WPA2 Enterprise are the encryption types that you're going to see most of the time now. The two most popular cracking tools for these encryptions are AirCrack and Reaver. AirCrack works a little bit better with WEP. Reaver works a little bit better with WPA and WPA2. They both take advantage of different issues within the wireless network. The latest really large bug, or perhaps vulnerability, within wireless networks that I know of was the crack vulnerability, which is spelled with a K, K-R-A-C-K, and that is actually a vulnerability that was found in the fundamentals of how the wireless network does encryption. You can actually also see something interesting called Wi-Fi broadcasting. Something that not a lot of people necessarily know is if you have a computer of any variety, this includes your cell phone, it's actually, if you have Wi-Fi turned on, it is continually broadcasting the names of Wi-Fi that you have saved. So let's say, for example, you have Wi-Fi on your phone. You've turned on Wi-Fi because you would like to save your data plan. So you probably have your home Wi-Fi credentials saved. You probably have your work credentials saved. You might have the school credentials saved. You might have your favorite restaurants or coffee shops credentials saved. Whenever you have your Wi-Fi on, your phone will actually be continuously saying, hey, are you my home Wi-Fi? Hey, are you this coffee shop Wi-Fi? Hey, are you my work Wi-Fi? Because it's always trying to get a better signal and a more familiar signal. So if you do something like, for example, AeroDump is usually the demo I would do in the classroom. Again, obviously can't really do it from home the same way. You can actually see what everybody is broadcasting for any Wi-Fi around you. So you can see who has Wi-Fi turned on and who doesn't. For those of you that have been to campus before and sort of know the layout for a little bit, Wi-Fi broadcasting can actually go far enough that if you are, for example, sitting in TC130, you can actually see everybody who's in TC130, all of the laptops and phones that have Wi-Fi on, and you can also see a decent portion of TC210. Now, another threat that's come for internet is the Internet of Things. The Internet of Things, or IoT devices, are the devices that we've started putting in our homes and cars and on our bodies to be able to track different information and supposedly make our lives easier. Now, a lot of the Internet of Things is going to be some very seemingly innocuous things, like, for example, the Ring doorbells by Amazon is part of the Internet of Things. Any of the Wi-Fi cameras, any of the smart devices that you might have, such as smart watches or run trackers. If you have any of the smart home speaker equipment or light bulbs, those are actually all part of the Internet of Things. What makes it an Internet of Things is these are devices that are internet connected, but you're not really accessing the internet with them in a normal way. You don't go onto your light bulb to go browse Wikipedia. You will generally have it connected so that you can turn your light bulb on and off without actually having to hit the on or off switch. So this home automation is one of the ways that we've seen the Internet of Things take off. We also have started seeing something called PANs or bands, personal area networks and body area networks. This is the wearables that we've started to see more often. Not necessarily the wearable glasses that kind of flopped. What we're seeing more now is the wearable smartwatches and things that attach to our cell phones. Now, home automation and Internet of Things has to be brought up in a security class because unfortunately, most of the Internet of Things has no security. So, one of the problems that we've run into with a lot of these Internet of Things devices is security was actually never even mentioned. IP cams are an example of this. If you go on any website, you can probably find an webcam for maybe 30 bucks. Most of these low end cams actually use the same chipset. There's 3 chips that are really popular right now. And in those chipsets, what the developer did was they actually hard coded in the admin password so that they could very easily access the devices for probably things like troubleshooting and restarting no matter what. These devices also only work properly in a lot of cases if they can do what you kind of call a phone home, where the device is actually checking in with the company that made it. So, part of what those IP cams do is the IP cam isn't something you access necessarily directly. You actually go to the website of the company and access the cam through that so called secure login. So that ends up creating its own set of issues because now instead of your router and your firewall at home protecting your camera, what's happening is the camera is actually punching through that to phone home, and then it's leaving this hole through all of your protections. Now, this is obviously more of a problem if, for example, they do things like hard code in a password for each of the cameras, because now all of a sudden you have something popping through all of your security with a hard coded in root password. I'm sure you can all see where the problem is there. Hardware for networking can also be an issue, as well as secure communications. Vulnerable devices are going to be things beyond the scope of what you normally think about. For example, how often do you update your printer? How often do you update your router? How often do you go in and apply security patches to them? Those are also things we have to think about when we talk about network threats. Now, firewalls are one of the ways that we can protect a network. A network based or host based firewall, at sort of a fundamental level, a firewall is taking the packets that are coming in or going out of a network as a whole, so like your whole home network or your host or your laptop or desktop or whatever, and looking at all of the packets that are coming in and going out. We can also have firewalls that are application based, so rather than looking at the packets, the letters coming in and going out, it's actually looking at the applications of what's running and deciding what is allowed in and what is not allowed in. And at its fundamental level, that's actually all a firewall is. DNS, or the domain name system, is actually how we can translate a URL, let's say google.com, into the IP address, whether it's IPv4 or IPv6, and how that translation happens so that when you go to google.com, you're actually able to find the Google servers with the Google search. Now, DNS does actually have some vulnerabilities. There are some issues with DNS hijacking, DNS cache poisoning, and some of what we've seen is there are some countries around the world that actually use DNS as the way they're going to enforce censorship. So if you live in a country where they do something like, for example, use DNS to forbid you from going to websites, what they're going to do is if you try to go to, let's say, google.com in China, where it's forbidden, it would actually translate google.com to somewhere else and it would direct you somewhere else. You would never actually get to real google.com, and they would also track who was doing it, when it was being done. We'll actually also see this happening in the US sometimes with some of our ISPs. They will actually use DNS hijacking to do things like serve up ads or track where you're going. As of summer of 2020, there's actually some current controversy because the ISPs are starting to sort of argue that they should be the ones providing DNS and you shouldn't be allowed to go to anybody else's DNS. And so there's a little bit of controversy starting to stir up around that. DNS cache poisoning, we can also do things where we can actually attack the DNS system and try to convince it to take us somewhere else, or do a DNS that is not a safe one, it's actually a malicious one, and then it can control where you're going. DNSSEC or DNS security is how we can split that up. You'll also see in some corporations they'll use what's called a split DNS, where they will actually have an internal DNS for the internal computers, and then they will have an external DNS for any external traffic. A DMZ or demilitarized zone is one of the ways that we can help protect our network. If you think about a DMZ as if we have packets coming in and they are requesting, let's say, a website, what we can actually do is direct those packets to the DMZ and the website, which is not on our internal network. And the reason that we'd want to do that is I always call them the problem children, but there are some services that are by definition more vulnerable, such as web servers, email servers, FTP servers, and VoIP servers. Those are more vulnerable by nature, and they're also the ones that the public is going to be accessing more likely. And anybody who's ever worked retail knows that everything is fine until the public shows up. So what ends up happening with the DMZ is we can actually use this sort of packet forwarding to be able to make sure that people asking for the website never get to our internal network. They're just sort of shunted off into the web server. So it's a little bit like having an entryway that's got a separate entrance for things that are more risky. Network monitoring and server monitoring, these are all things that network admins will do. A good network admin will be testing the network and paying attention to what's happening on the network so that they can figure out if their network is starting to get to be a problem, if they need to upgrade their hardware. They can do things like figure out if they have bottlenecks somewhere, stuff like that. Logging is something that we do when we are testing our network and keeping track of what's happening. We want to keep track of any issues. We also want to do some baselines so that we know what is a normal amount of traffic for, say, a Friday morning, so that we can figure out, is this a normal amount of traffic that I'm seeing, or is this an abnormal amount of traffic? We want to have dedicated log servers so that all of the information that we're gathering about our networks is being saved somewhere, and we're making sure that none of this is changed in any way. And then we want to be able to go back and actually do a review or an audit of our logs to see if there's anything funny. We can also use this as a traceback so that if we have an incident, we can do some basic forensics. Now, network management, there's something called red flags. Red flags are basically like a thing that would happen that would make me concerned. So, for example, if I am a network admin and I see a spike in traffic at 3 a.m., I might consider that a red flag because I don't have a reason, or I was not notified of something happening at 3 a.m., and so that could be somebody is trying to attack the system. Now, we also have something called whitelists and blacklists. As of summer of 2020, there's been a lot of conversations about race, racism, and being anti-racist, and so there are starting to be some conversations about changing the vocabulary away from whitelist and blacklist. However, that hasn't happened yet, so you're likely to still see this. A whitelist is where we say the only places that you can go are on this list. A blacklist is where you say you can go anywhere except for these places. And that's one of the ways that we can actually set up protection. So we can either forbid specific things, like for example, forbid Facebook for all of our workers. We could also have a whitelist. Perhaps we only have some places that you are allowed to go. For example, some countries might have a set of a dozen web pages that you're allowed to see. That would be on the whitelist, and you're not allowed anywhere else. False positives and false negatives are something that can happen with red flags. A false positive means that we think something has gone wrong, but it hasn't. A false negative is we think everything is okay, but it's not. And so as you're making your policies, you have to figure out which one is better for you. Would you rather have no idea that something is going wrong and something is going wrong, or would you rather be worried about something going wrong when everything is fine? Now, obviously, ideally, neither one of these would happen, but it is something that you have to worry about. Now, the lab for the week is a shorter lab than normal. There's a zip file that's attached to the lab, and you're basically going to follow an exercise where you run a jar file and you're going to try creating some different rules for a firewall. Play with it, see what happens. There's some questions that you'll need to answer. It's not super heavy lifting because we are actually coming up on the midterm. Now, for the midterm this year, instead of a written test, we're going to be doing a scavenger hunt. The scavenger hunt has things you have to go find with assigned point values. As we get a little bit closer to that, I will be talking about that during the live streams. I can also create an FAQ video if there are questions. Please let me know if you have questions.